Hi, thanks for joining us today as we continue our adventure down 5-6, the last lesson of Chapter 5. So, in the previous video we talked about what definite integration was and how our calculator can show us some stuff. But what if we didn't have our calculator? What if the knife-wielding lunatic who asks us these questions doesn't let us get our calculators out? How can we do signed area without using a calculator? It's going to be pretty simple and pretty similar to what we just did. We're going to first graph this function. There's a question just like this on the test, unified test. Oh, that's a little too curvy for me. Sure, whatever. Actually, that's too much. Okay. I like a little more space than that. One way to graph absolute value functions, a very useful way that I don't think I've covered in any other video yet, is to graph the inside of the absolute value function, which would be a line with a slope of 2, a y-intercept of -1, so we'll call that 0, -1. The y-intercept is 0, -1. An x-intercept, which you can get by setting this equal to 0, of 0, 1/2. Sorry, 1/2, 0. Man, I'm off the game today. And I would graph this as a dotted line. Hopefully slightly less curvy. Hopefully your line looks a lot nicer than my line. So in the dashed line, I've graphed the line y equals 2x minus 1. And now I shall graph the line, I should have picked a different color for that. Whatever. Now I'll graph the line y equals absolute value 2x minus 1. So as I talked about in the previous video, the absolute value transformation takes all the negative bits and reflects it up. So importantly, an absolute value transformation will keep all of the x-intercepts the same. It's a very important fact for what we're about to do. So that bit all looks the same. This bit gets reflected up. I'll mark its new y-intercept, which looks a lot taller than it probably should be, as 0, 1. Okay? So that's the first step. Get a graph. Now, something you have to get good at is that this says, give me the area starting from x equals 0. X equals 0 would be this line. Stopping at x equals 3, which we'll just say is like way out here. Doesn't have to be perfect. Between the x-axis and this whole stupid function we have. Between the x-axis and that function. So, if I want the area between the x-axis and that function, I'm going to start at the function and go to the x-axis, straight to the x-axis. So that would be all this junk. I hope you can start to see it. You draw a few lines, get a feel for it, and then you can go ahead and make the solid shape. The same thing over here. Oh, it's just going to be this big old shape. You know what I should have done? Anything else. Build it. Use a different color. You'll see why. So, I don't have a good way of getting the area of this bow tie type shape. But what I do have a good way of doing, whoa, no, not that, is getting an area, see, that's what I'm saying, is getting an area, we'll just deal with it. right, guys, of getting the area of both of these shapes individually. So, this green triangle, spoiler, would have an area of 1/2 base. What the heck? Base. The base has a distance of 1/2 this x-coordinate minus 0, or 1/2. And the height is a 1 minus the y-coordinate minus that y-coordinate. So the green triangle would have that area. Whereas this purple triangle, this length would be, remember that's at 3, so it's 3 minus 1/2, right minus left. So I add the purple area, which is 1/2 times 3 minus 1/2 is actually 5/2 times the height. Now, this is definitely y equals 0, but how tall is this? Well, for that, I need to know the coordinate of that point right there. And that point would be 3, comma, absolute value of 2 times 3 minus 1. Plugging it into the integrand, which is a fancy way of saying 3, comma 5. So that triangle is 5 tall, or 5 minus 0. That's it. This problem's on the test. Super duper important. You should be able to make a picture like that and calculate the area lickety-split. To test yourself on this question, you know what? Let's hold off on that for now. Sorry. Okay. Let's get familiar. Okay, one more time. I'm going to review what this means. The area from 0, starting from x equals 0, stopping at x equals 3, between the curve, absolute value, minus, to the x-axis. The other one that you'll see often, including in the AP test, set up a definite integral to find the area of this region. Well, we would want the area to be, okay, so we want an integral, set up a definite integral. All right. What would the integrand be here? The integrand would be, what are we under? What are we between? We are between the x-axis and this parabola. So my integrand is the equation of the parabola. I misspoke. It's not the equation. I've seen many people lose points for doing that. You lose points. No. Bad. So that's the integrand. The rightmost bound, we're going to start counting the area at x equals 0. We're going to stop counting the area at x equals 2 with respect to x. That's it.